Hello students, so here we are with the question first of the exercise 3.5 for the chapter pair of linear equations in two variables. So the question first is, which of the following pairs of linear equations has unique solution, no solution or infinitely many solutions? So if we focus over the term unique solution, what it signifies is intersecting lines. Okay. It means that the lines which are being represented by these two linear equations being provided in the problem must be intersecting at some point, and that point will be the solution for those equations. So as we have got only one solution, so these equations will be called having a unique solution. And now coming to the term no solution, it means pair of parallel lines. Okay, that is, parallel lines are being represented by the two equations being provided in the question. And also it's been given infinitely many solutions. It means the lines are coincident line. That is, they're not different line but the same line. That is, one line is being lying above the another. So the pair of equations being provided might be having unique solution, no solution or infinitely many solutions. So three cases are possible. In case there is a unique solution, fit it by using cross multiplication method. So in the question it's been said that if there exists a unique solution for the pair of linear equations being provided, then only we need to proceed further and solve them by using cross multiplication method. So before doing this question, let us see what the unique solution condition says. So linear equations are said to have unique solution, or we can say lines are said to be intersecting line only and only if a1 by a2 is not equal to b1 by b2. Comparing them with the standard equations, that is a1x plus b1y plus c1 is equals to 0, and the second linear equation be a2x plus b2y plus c2 is equals to 0, means here we have assumed the two standard linear equations, and the condition for the linear equations to have a unique solution is that ratio a1 by a2 should not be equal to the ratio b1 by b2. Okay, so if this condition has been fulfilled by the linear equations provided in question, then only we will proceed further and solve them by using cross multiplication method. Now the question arises what the cross multiplication method is. So in order to understand the cross multiplication method, let us consider these two standard form of the equations. So now write the coefficient of x, y and the constant terms in such pattern, that is, first write b1, b2, then write c1, c2, then write a1, a2 and then write b1, b2. That is, just write the elements, or we can say the coefficient of first y variable, then constant terms, then x variable coefficient and then again y variable coefficients. From here we will be obtaining three ratios whose numerators are x, y and 1 respectively. That is, from this very elements, three ratios will be obtained whose numerator will be x, y and 1. And then the question arises what the denominator gonna be. That is, what will be the denominator of the ratio where x is numerator, where y is numerator and where the constant term, that is 1, is in the numerator. So in order to get the denominator of the first ratio, let us consider a window which includes the element b1, c1, b2 and c2. Okay. Now multiply the top left element with the bottom right element, that is b1, c2, and then minus sign and multiply the elements top right with the bottom left. So here it comes out to be b2, c1. Okay. So here we have obtained the denominator for the first ratio, which is equal to B1 C2 minus B2 into C1. Now coming to the second window, which includes the elements C1, C2, A1, A2. Okay. So if we consider this window, which includes the elements C1, A1 and C2, A2, now the first term will be C1 into A2, that is C1, A2 minus C2 into A1, that is bottom left with the top right element. Okay. Now we have obtained the second ratio as well. Now coming to the third ratio. Now consider the window which includes the elements A1, A2 and B1, B2. So now for the third ratio denominator, it will be A1 into B2, that is top left with the bottom right minus top right with the bottom left, that is B1 into A2. Thus we have obtained the three ratios whose numerators are x, y and 1, and the denominators have been obtained from this very pattern, and considering three windows each time and multiplying the elements in some definite pattern, right? So from here, in order to get the value for the variable x, that is for x, what we need to do is to equate the first ratio with third ratio. As in the first and the third ratio, the variable is only x, so we can easily get the value for the variable x. And for y, what we need to do is to equate second ratio, that is y divided by C1A2 minus C2A1 with the third ratio, that is 1 divided by A1B2 minus B1A2. So we have obtained the value for the variable x and y respectively, which was our main target, right? So this was all about the cross multiplication, that how we need to apply the cross multiplication method. Now we will be doing the question and will be more clear how the actual question and the solution by using the cross multiplication looks like. So now coming to the A part. In the A part, the two equations being provided are x minus 3y minus 3 is equal to 0, and the second equation is 3x minus 9y minus 2 is equals to 0. So these are the two linear equations being provided in the first part of question first, right? So the first step we need to follow is to find whether or not these linear equations have a unique solution. That is, we know the condition for the linear equation to have a unique solution is A1 by A2 is not equal to B1 by B2. So here what A1 by A2 is 1 by 3 and B1 by B2 is minus 3 divided by minus 9. So on simplifying, I'll be getting 1 by 3 and 1 by 3. Clearly A1 by A2 is equal to B1 by B2. Also, we check for C1 and C2. Here C1 by C2 comes out to be equal to minus 3 divided by minus 2. That is, it is equal to 3 by 2. So, as we are clear from here that A1 by A2 comes out to be equal to B1 by B2 but not equal to C1 by C2. And as we know, whenever such condition arises, that is A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then the pair of linear equations are said to have no solution. That is, there exists a pair of parallel lines. So, no unique solution have been obtained, so we won't proceed further, right? Now, coming to the B part. Here, the two equations being provided are 2x plus y is equals to 5. And the second equation is 3x plus 2y is equals to 8. So these are the two linear equations. So the first step again is to check whether or not these pair of linear equations have a unique solution. For that, we will be finding the ratio A1 by A2 and B1 by B2. So in these pair of equations, A1 by A2 is 2 by 3. And the ratio B1 by B2 is 1 by 2. Clearly, the ratio A1 by A2 is not equal to B1 by B2, which means the conditions for the linear equation to have a unique solution have been fulfilled. So these pair of linear equation will be having unique solution. And as the pair of linear equation are having unique solution, we will proceed further. That is, we will solve this pair of linear equation by using cross multiplication method. So as we have learned earlier what the cross multiplication method is, so we will be writing the coefficient of x, y and the constant term in some definite pattern first. That is b1, b2, 1, 2, then c1, c2. Just compare these equations with the standard form. As in the standard form, we have taken constant in the left hand side, but in the equations being provided in this part, the constant terms are on right hand side. So take this constant term towards left hand side. So this will be minus 5 and this will be minus 8. Again a1, a2, that is 2, 3, and then b1, b2, that is 1, 2. From here, three ratios will be obtained whose numerator will be x, y and the constant 1. So in order to find the denominator for the first ratio, I'll be having the window which includes the element 1, minus 5, 2 and minus 8. So on multiplying as we did in cross multiplication method, it will be minus 8 minus minus 10. The second ratio denominator will be minus 15 plus 16. And the third ratio denominator will be 4 minus 3. That is 2 into 2 minus 3 into 1. Right. So from here it comes out to be equal to 2 by x by 2 is equals to y by 1, which is equals to 1. That is, three ratios have been obtained. And as we know, for having the value for the variable x, we need to equate x by 2 with the third ratio, that is 1. So equating the first ratio x by 2 with a constant term, here x comes out to be equal to 2. Means we have obtained the value for the variable x. Now for variable y, we will equate second ratio with the third ratio. That is y by 1 is equals to 1. From here, y comes out to be equal to 1. So means we have obtained the values for the variable x and y, which is 1 and 1, and this is the solution for these very linear equations. That is, this is a unique solution at which the lines will intersect each other. Now coming to the C part, here the two equations being provided are 3x minus 5y is equals to 20, and the second equation is 6x minus 10y is equals to 40. So again the first step is to find the ratio a1, a2 and b1, b2. So in this very question, a1 by a2 will be 3 by 6, b1 and b2 will be minus 5 by minus 10, and c1 by c2 will be minus 20 by minus 40. So on simplifying this, I'll be getting 1 by 2, 1 by 2 and 1 by 2. That is, a1 by a2 is equals to b1 by b2 is equals to c1 by c2. And we know whenever such condition arises, that is a1 by a2 comes out to be equal to b1 by b2 and equal to c1 by c2, then the pair of equations are said to have infinite many solutions. Means the lines which will represent these very linear equations will be having many solutions. Right. Now coming to the D part, here the D part, the two equations being provided are x minus 3y minus 7 is equals to 0, and the second equation is 3x minus 3y minus 15 is equals to 0. So again our first step will be to check whether or not these pair of linear equations have some intersecting point, or we can say in other words a unique solution. So here a1 by a2 will be 1 by 3, b1 by b2 will be minus 3 by minus 3, and c1 by c2 will be minus 7 by minus 15. So on simplifying, a1 by a2 will be 1 by 3 and b1 by b2 will be 1, means a1 by a2 is not equal to b1 by b2. Right. So this was the condition for the pair of linear equation to have a unique solution, means these pair of equations will definitely be having unique solution. So now the next step is to find that solution, that is that very point at which these lines will be intersecting. So as it's been asked to solve these equations by using cross multiplication method, so again by writing the coefficients of x, y and the constant term in some definite pattern, here we will be writing minus 3 minus 3, minus 7 minus 15, 1 and 3, and then again minus 3 minus 3. From this, three ratios will be obtained whose numerator will be x, y and the constant 1 term, right? So now applying the window over the elements minus 3, minus 7, minus 3 and minus 15, the denominator of the first ratio will be 45 minus 21, that is minus 3 into minus 7. The second ratio denominator will be minus 7 into 3 comes out to be minus 21, then again minus and minus 15. The third ratio denominator will be minus 3 minus minus 9. So on simplifying, I'll be getting x by 24 is equals to y by minus 6 is equals to 1 by 6. So in order to get the value for x, so for x, I'll be equating the first ratio with the constant term. So here, x comes out to be equal to 4. And for y, I'll be equating second with the third ratio. So from here, y comes out to be equal to minus 1. Means the unique solution for these very pair of linear equation is 4, minus 1. So this is a unique solution of these pair of linear equations. So this was about the first question of exercise 3.5. I hope this question is clear to all of you.